Hello everyone, I'm going to talk to you today about finding measures of angles that are in and around circles. So in this lesson we will explore how line segments and lines create angles that are on or inside or outside of circles that we can determine the measure of. So we're going to see how the angles around circles can be measured based on the relationship with the circle. And so to do that we have to understand how an angle measure and the degree measure of an arc work together. So first, let's talk about what an arc is. If you look at this portion right here, we know that a circle represents a rotation of 360 degrees. And this little notation right here with a little curved segment over the top of the letters AB means arc. So the arc AB is the portion of the circumference of the circle. So the circumference is like the perimeter of the circle, and the arc is just a part of that. So the angles that we are going to measure, they depend on the measure of the arcs that they intercept, or the ones that they kind of extend out to. And we'll see what this looks like in a minute. Now, one important arc to talk about is when you have a semicircle. And how do we have a semicircle? Is when you have a diameter that's drawn. So let's see what a diameter would look like. So a diameter is a special kind of chord that's in the circle that goes right through the center of the circle. And we've seen this all the way from when we talked about linear pairs of, two angles that form linear pairs, that they create an arc that's a 180-degree arc. Okay. Now, there are three important angle relationships that we need to understand about circles. And all the other angles that we're going to find, we're going to use definitions and theorems that we have previously learned, which I'll refer back to in a minute. But the three important things to know, the first one is called a central angle. And a central angle is an angle that's formed by two radii. So a radius WO and YO, those segments are each a radius of this circle O. And together they form an angle WOY. This angle is called a central angle, and the measure of this angle is equal to the measure of the intercepted arc. So when I measure the angle that is the rotation from W to Y around point O, the intercepted arc is the same as this arc right here. Okay, that's what we mean by intercepted arc. It's the arc that is kind of extended out, or that is intersected through the rays of this circle. Okay, and whatever the measure of this angle is, that arc measures the same thing. So if I'm going to guess, I'm going to say that this is maybe a 70-degree angle. Which means that this portion of the circle is about 70 of the 360 degrees in the circle. Okay, so there's the first one. A central angle is when the measure of the angle is equal to the arc, and we can tell that the vertex of the angle, is the center of the circle. The next one is an important one called an inscribed angle. And this is an angle formed by two chords. In this case, the segments WX and WY are the two chords, and the vertex X is on the circle. So the central angle, you have the center of the circle is where the vertex is. In an inscribed angle, the vertex is on the circle. Okay, so now the measure of this angle depends on the measure of the intercepted arc that's over here, except this time it can't be equal because it's not a central angle. Instead, the measure of the angle is exactly half the measure of the intercepted arc. So if I was going to say like this arc was about 80 degrees, okay, 80 of the 360 degrees in the circle, that means that the measure of this angle would have to be 40 degrees because the measure of the angle is half the measure of the intercepted arc. And then the last one is kind of similar to the inscribed angle. It's when you have an angle formed by a tangent and a chord. So see in this picture, you have a tangent segment, STU, it's tangent at the point T, and then you have the chord RT. So this point T is a vertex of the angle. And so if I was going to measure, one of these two angles that create this line, if I was going to measure the angle RTU, see, sometimes we have a hard time seeing that this angle is intercepting the arc that goes around the circle from point R to point T. Okay, so if I was going to measure this arc, let's say this arc was maybe 200 degrees. 200 out of the 360. I know it's definitely more than 180. Maybe it's more than 200, but 200 is a pretty safe bet. So if I was going to say this arc was about 200-degree arc, that means now that since this point T is on the circle, it's an angle formed by a tangent segment and a chord segment, then again, the measure of this angle is half the measure of the intercepted arc. So this angle would be about a 100-degree angle. Okay, and here's a good reason why it has to be half. Well, because if you were going to measure the other side, the other angle that's in here, this angle right over here, okay, how big does that angle have to be? Well, that angle is also formed by a tangent and a chord. Now, we know that a circle is 360 degrees, which means that the measure of the other side of the circle has to be a 160 degrees, because 160 degrees plus 200 degrees is 360. Which means that now the measure of this angle from R to T to S has to be exactly 80 degrees. And now to then further prove this, these two angles, STR and RTU, those angles are called a linear pair of angles. That's something we talked about way back in Unit 1. And those two angles form this straight line, STU. So those two angles also have to add up to 180. So that's a good reason why these two angles have to be half of the intercepted arc, but also they have to add up to 180. Okay, so those are the three angle relationships that we are going to keep referring back to. And if it's not one of those three angle relationships, then it's going to be something else that we've learned along the way. Okay, now here's a couple special cases for these angle relationships. One of them is when you have an inscribed angle in a semicircle. Okay, so this is when we have an angle that's formed by two chords, and the angle that I'm referring to is the angle between the chords FG and GH. See, those two chords form the angle FGH. Now, since this right here, that point right there represents the center of the circle. So this segment from F to H represents a diameter of the circle. So one thing I know is that this arc on the other side of the circle, the one that goes from F through J to H, this arc right here has to measure 180 degrees. Okay, and because it's exactly half the circle. And because of that, that means that this angle that's right here, the angle FGH, must be a 90-degree angle because it's exactly half of that. So one special case, or what's special about this, is if you have an inscribed angle where the end points of these chords are the end points of a diameter, then that angle has to be a 90-degree angle. So just kind of like special little case. Okay. Similarly, here is an extension of the tangent chord or tangent angle is that when you have a diameter or a radius that connects with a tangent. So in this case, you see I have a radius ST that connects to the tangent at point T. But if I was going to just extend that to make it a diameter, I would go like this. Now, it doesn't matter if it's a radius or a diameter, that where this chord meets that tangent, it has to be exactly half of an intercepted arc. Well, because it's a diameter, again, that this arc has to be exactly a 180-degree arc, which means the measure of this angle is, again, just a 90-degree angle. So whether you have an angle inscribed in a semicircle or where you have an angle where you have a diameter meeting a tangent, those have to be half of 180. They both measure 90-degree angles. Okay. One more little special case about an inscribed angle is when you have an inscribed polygon. Now, in this case, you're looking at an inscribed quadrilateral, where each point of the quadrilateral is a point on the circle. And one kind of like special little thing about this that happens is that when you look at angles opposite of each other, the measures of angles opposite of each other, so like in this case, it says the measure of angle B that's right here, and the measure of angle D that's over here, those angles have to add up to 180 degrees. That's true because of this fact like this. Well, if we talk about angle B, this angle B is extends to the point A and to the point C. So angle B intercepts the arc from A to C. Okay. Now on the other end, this angle over here, angle D, this angle intercepts the arc that goes from A to C the other direction. Okay, so if we consider that together, these two arcs, the one from A to C that I kind of traced in purple and the one from A to C that I traced in red, together they have to add up to 360 degrees because that's the entire circle. And each one of these angles is exactly half of that. So if I add up the angles, it has to be half of the sum of the circle, which is 360. So that's kind of why this case happens, that when you have opposite angles in an inscribed quadrilateral, those have to add up to 180. Okay, so now we're ready to look at some questions and to like see what happens when it's not one of these other special kinds of angles. And starting off this relatively simple here, we have, it says circle O, and you have segment ML is a diameter, and chords MN and NL are drawn. So that's what describing what the picture is. And they give you one piece of information. They say, if the measure of the arc NL is 124 degrees, then let's find these other things. Okay, and so what I'm going to do is I'm going to also kind of like justify my work as I go. All right, so the first thing I'm going to do is I'm just going to take this and say, okay, how can I use what I see to find more information? Well, this arc is 124 degrees. And the first thing that pops into my mind is that because segment ML is a diameter, that means it splits the circle exactly in half. That means that the arc from M to L on this side has to be a 180 degree arc, and on the other side also 180. So if I take 180 and I subtract 124, that means I have 56 degrees left over. Okay, so 56 degrees must be the measure of the arc from M to Z. So where they say find the measures of each of these letters X, Y, and Z, each of these things, I know that Z has to be 56. So just to kind of justify what I got here, I said that the measure of arc Z is equal to 56 because, misspelled that word, because you have a diameter makes a semicircle that measures 180. So together, those two arcs have to add to 180. That part has to be 56. Okay, moving on. I'm trying to find both angle X and angle Y. So I'll try to find X next. Let's see if I can do that. So angle X, I would describe as being an inscribed angle. The measure of this angle is inscribed, that angle is called inscribed because the vertex, point M, is on the circle O, okay? So since that's on the circle, then I'm going to kind of trace this out from M to the point N and from M to the point L. And so the measure of the angle X has to be exactly half of the 124 degrees. So if I take 124 and I divide it by 2, then I get 62. So again, just to justify my work here, I said the measure of angle X is 62 because it's an inscribed angle, so it is half of the intercepted arc. Now, you may have to justify your work on certain questions, but not always. I'm just doing this so that you can try to help you understand where I'm getting these things from. Now, the last thing I got to do is try to find the measure of angle Y. So in this case, let me go over here and I want to find angle Y. So angle Y is the angle, again, I would describe this as being an inscribed angle. And it's inscribed because the point N, that vertex, is on the circle. The segment NM is a chord and NL is a chord. So this is another example of an inscribed angle. So the measure of angle Y is exactly half of the measure of its intercepted arc. So it goes to the point M and then all the way around here to point L. So since that arc is 180, or because the segment ML is a diameter, that this has to be a 90-degree angle. So the measure of angle Y is 90 because it's an inscribed angle, so it's half of the intercepted arc. Now you could also describe it as being an inscribed angle within a semicircle. That's another good reason why it would be a 90-degree angle. Okay, so now let's check this one out. All right, so now I have examples I have two secants. BEA and BGC are both secants drawn to circle O. Now I also see I have a chord that goes from from point A to point G. I'm told that the measure of the arc from E to G is 30 degrees, and the measure of of arc AC is 82. And now the question asks me to find the measure of angle ABC. ABC is this angle over here. This angle ABC is an angle outside of my circle O. So I didn't show you how we can do this. This is not one of those three types of angles that we talked about. So what I have to do instead is I got to think about some other ways I can do this. Now, one thing I notice is that the angle B is an angle that's outside the circle, but also inside of a triangle. Do you see the triangle that angle B is inside of? And if you can find the other angles in that triangle, perhaps, then you can find the measure of angle B, because we learned way long time ago that the three angles of a triangle always add up to 180. All right, so I'm going to try to see if I can determine the measures of the other angles in that triangle. So I'm going to look over here and say, okay, can I find the measure of this angle A? That angle A is a point on the circle, so it's an inscribed angle. Do I know the arc that's opposite of the angle A, or the arc that is intercepted by angle A? Yes, it's a 30-degree arc. So I can tell that the measure of angle A has to be a 15-degree angle, because it's exactly half of the 30-degree arc over here. Now, the next angle that's inside of the triangle is the one from A to G to B. This angle right here is another one that I do not have a formula for. It's because I don't have an equation that says, here's how you find an angle that's formed by a secant and a chord. There was nothing for a secant and a chord, only an inscribed angle, a central angle, and an angle formed with a tangent and a chord. So I don't have one for that. But again, if I don't have an angle for this one, can I do something else? Well, the angle AGB is very much related to the angle AGC. Because angle AGC, these two angles are right next to each other on this straight line. Those are called a linear pair of angles. So if I can find the angle AGC, then I can find the angle AGB. And then I can determine finally what the measure of that angle B is. So here I'm going to say, well, can I find this angle right there? Okay, well, yeah, because that angle, point G, is on the circle, and it's formed by the chord GC and the chord GA. So in this case, this angle is an inscribed angle, and it's got to be exactly half of the arc from A to C. So since that arc's 82, then this angle must be 41 degrees. Okay, now my next step would be to determine the angle next to that, adjacent to the 41-degree angle, which is this angle over here, the one that I said was AGB. So since that angle on the left side of that line is 41 degrees, and together they have to be 180 because they're a linear pair, they add up to 180, then I'm going to say that the one on the other side here is 139 degrees. Okay, and now I can finally get to the angle that I wanted in the first place, which was the measure of angle B. And the reason I can find that is because I know 2 out of 3 angles in this triangle. So if I add these two up together, then I can get the measure of angle. So I said, just to justify each one, we got the measure of angle A because it was an inscribed angle. We got the measure of angle AGC because it was an inscribed angle. AGB was a linear pair to AGC. And then finally, the measure of angle B must be 26 because the triangle angle sum is 180. So there is my final answer right over here. Whoops. My final answer is that this angle must be a 26-degree angle. Okay, so when you have angles that are not one of those 3 cases, you have to look for some other things like linear pairs or triangles to help me find what that must be. Okay. Now, here we go again, and we have a diagram of circle O. So you see point O is the center of the circle. Point E is not the center of the circle. Point O is, and it's very important to see the difference between those two things. Now, in this case, we have the measure of angle AED is 116 degrees, and arc AD is 132 degrees, and the goal is to find the measure of the arc from C to B. So let's go ahead and label that. Now, one thing that's important to recognize here is you notice how the angle right here that's 116 degrees is not equal to the arc over here that's 132. That's again because the point E is not a point in the center of the circle. If E was the center of the circle, then angle AED would be called a central angle, and then it would have to be equal to the 132. But since E is not the center, then it's not equal. Instead, I'm going to look for other relationships that I do know what have to be true about this circle. So I'm looking for inscribed angles, and I'm looking for linear pairs, and I'm looking for triangles. Well, I can see that I've got some triangles, but I don't have any angles within those triangles yet. Okay. What I do, however, see is when you have points on circles, point A is on the circle, point C is on the circle, point B, point D, all four of those points are on the circle. And when you have an when you have an arc on the circle, if you can recognize where you have an inscribed angle that kind of like opens up to or intercepts this arc, then we can find the measure of this angle. So angle B is an inscribed angle, and it intercepts the arc from A to D. So because of that, I can say that angle B has to be exactly half of 132, okay? So angle B has to be 66 degrees. Next thing I'm going to do is I'm going to look for other things that I know must be true. And where I see lines that intersect, I can maybe find some linear pairs that are supplementary. So since I have an angle that's 116 degrees right here, I know the point O is throwing me off. It looks like 166, but that's a 116 degree angle. Then what I can do with that is I could use that to find the measure of the angle that's a linear pair with it. So see, I'm tracing this line that goes AEB. So since this is a 116 degree angle, then I can use that to find what this angle is right here, like BED. Okay, so let's go ahead and do that. Okay, so I determined that that angle has to be a 64 degree angle because together 116 plus 64 makes 180. Now again, I'm trying to get over here to get to this arc. And so this arc that I'm looking at on this side is an intercepted arc by the angle D that's over here. All right. And yes, it is intercepted by the angle CEB, but because that point E is not one of our key angles that I'm looking for, I'm looking for the angles that I can find either on the circle or in the very center of the circle. If it's not on the circle or in the center of the circle, I kind of want to stay away from that one. But what I can do is I can find the measure of this angle D because there's a triangle right here, and I now know two of the three angles in the triangle. And once I know the measure of angle D, then I can use that to find the measure of this arc from C to B. That's the intercepted arc from that angle D. So now let's go ahead and do that. So the measure of angle D must be 50 because the triangle angle sum is 180, and therefore the measure of the arc BC must be 100 because it's got to be double the measure of the inscribed angle. Okay, so here we go again, using these other relationships, linear pairs, triangles, angle sums, along with the new ones that we learned for the angles in and on the circle. In question 4, we have in this diagram, the segments DE and BC are parallel to each other. Now, here's one fun fact about circles, that when you have chords that are parallel to each other, what that means is the pieces of the circle, the arcs of the circle that are intersected by these chords, that meaning like this arc right here from D to B, and then this arc from right here from E to C, those arcs have to be equal to each other. Whenever you have lines parallel cutting through a circle, the arcs that they cut apart, those parts of the circle always have to be congruent to each other. Now, in this question, I'm asked to, I'm given that these segments are, those chords were parallel to each other, and that this segment is a diameter, and the measure of angle DCB is a 25 degree angle. And the goal is to figure out what the measure of the arc from D to E has to be. Okay, so now again, I know that this point C is a point on the circle, and therefore that this angle C is called an inscribed angle. when that's the case, the measure of the intercepted arc has to be double that inscribed angle. So I can say for certain that this arc is 50 degrees. And I know that, like I said about the parallel lines here, that the arc from E to C must also be 50 degrees. And now I want to try to see what else can I use to figure out figure out what the arc from D to E has to be. Well, a diameter creates a semicircle. So the entire arc all the way around here is exactly 180. And since I've already got a 50 and a 50, I've got 100 degrees so far. That means that this arc must be an 80-degree arc. Okay, so I'm not going to go through the steps of justifying this time, but the measure of the arc DE must be an 80-degree arc. And I've kind of talked about each one, but I will put this little bit down. So just as a little reference here, parallel chords create congruent arcs. So that was the little piece there about why those both had to be 50. All right, now I hope you stuck around for this last one because this is certainly the most challenging of our questions. And now we have to take a look at this question where there's kind of a lot going on in this picture. And not only that, but I have this little tidbit of information up here about how to calculate the measures of these arcs. And now what you're looking at here is that we have, oh, I mislabeled this. It says circle O, but it really should be circle G. But you have a secant called IJH, and you have ILK is also a secant. Then we have a chord from J to L and J to K and H to K. All of these are drawn so that. Now, the way to read this is that we're talking about a ratio, and it's a ratio of 4 different pieces. The measure of the arc LJ to the arc JH to the arc HK and to the arc KL is in a ratio of 5 to 13 to 10 to 8. Now, the way ratios work is the same thing with similarity, that, like, for example, if I'm just looking at 5 to 10, that means whatever the arc from L to J is, the one from H to K is exactly double that arc. Okay, that's how ratios are. But what I got to do is I got to kind of figure out is how much does each part actually measure? You see, when I put all 4 of these arcs together, L to J, and then J to H, and then H to K, and finally K back to L, I started at L and I made my way all the way around back to L. So what I can say for certain is that these 4 arcs add up to a 360-degree rotation. And now, since I know that, I can use that to kind of create an equation that helps me figure out how much each one has to measure. Okay, so the equation I'm gonna write looks like this. It looks like this: 5x plus 13x plus 10x plus 8x equals 360. Now, what this is x kind of is like my multiplier, like how much bigger than this does that have to be. So now I'm just going to solve this equation for x. Very simple algebraic equation. Let's solve for x. So when I add 5 plus 13 plus 10 plus 8, you get 36x equals 360. Divide by 36, x is 10. So what does that tell me? It tells me that my arcs are in a ratio of 5 parts to 13 parts to 10 parts to 8 parts. It means that each part is worth 10 degrees. So the measure of the arc LJ has to be a 50-degree arc. 5 times 10 is 50 degrees. And then 13 times 10 is 130 degrees. And then 100 degrees. And then lastly, 80 degrees. Okay, so there's step 1. Now I've got a lot more information to use to kind of continue from here. And it says, here's the things I want to find. Can I find the measure of arc LK? I already did that. That's 80 degrees. Okay, and then from there, I want to try to find some angles. Well, basically what I'm going to do is I'm going to look for the angle relationships that I know must be true. Now, the one thing I see is I'm looking for angles that are in the center of the circle. I have none because there's no angles around point G. But I'm also looking for angles on the circle. I have a lot. Point H, point K, point L, point J, all of those points are on the circle. Whenever you have an angle on the circle, we might be able to find an inscribed, or call that an inscribed angle. Now, the last thing I'm looking for is for part C here, what's the measure of angle HIK? That's this point over here out of the circle. So for me to find what angle HIK is, I'm going to have to like kind of put this as part of a triangle and then see if I can find the other angles in that triangle. So let me just kind of like start working my way through this, kind of like figuring out through this puzzle what things have to be. So I'm looking for inscribed angles based on the arcs that I already found. So okay, so I have a 50-degree arc right here from L to J. That means that if I can find an inscribed angle that intercepts the arc from L to J, it must be 25. So which angles inscribe go to the arc LJ? One of them is this one right here. This angle LKJ has to be a 25-degree angle. Okay. Or if I, or I could also look at it from this side. Can I find the measure of the inscribed angle that's right here at this point K, JKH? Well, that angle opens up to the arc or intercepts the arc from J to H, 130. So this angle has to be a 65-degree angle. Okay, and I just kind of keep looking around, more inscribed angles. H is on the circle. This is an inscribed angle. It goes to the arc from K. Now check this out. It goes from H to K and H to J. If I combine these two together, 50 and 80 makes 130. So this also has to be a 65-degree angle. Okay, keep working your way around. So I have an inscribed angle at point J, from J to H, from J to K. This 100-degree angle, or arc rather, is opposite that. So this is a 50-degree angle here. Okay, point J is on the circle. Point J extends to point L and also to point K. So this has to be a 40-degree angle. It's half of 80. And now if I have one more point on the circle, that's point L right here. And point L extends up to point J and then also over to point K. So from J all the way to K is 130 plus 100, or 230. So what's half of 230? It is 115. Now, I think I've got all the angles in these little bits and pieces here. So all I was looking for is all these inscribed angles, points on the circle, chords extending out, just finding all these inscribed angles. So now, did I ever find the measure of angle HKL? There's H, there's K, there's L. Yeah, that one, I got it already. It was 65. But I need to get to this angle I that's over here. So I'm just going to look for, can I put this as part of a triangle? And you can make this as part of lots of triangles, but pick one triangle and then let's see how much we know about that one triangle. I'm going to go with this one. So I traced the triangle from I to H to K just because I already knew the measure of this angle H and I already knew the measure of this whole angle K. I had to add 25 and 65 together to make 90 degrees. But with those two numbers, I was able to figure out what the angle HIK has to be. It's exactly 25 degrees. So had you chose a different triangle, then you would have to figure out, what the three angles of that triangle is. But any triangle works. All triangles have an angle sum of 180. So that's the end of our show for today. Hopefully you were able to stick around with me the whole time. I hope you can use this to answer your practice problems now. Thanks so much. Have a great day.